Hello, welcome to my channel. I am Ameya and we are discussing about control systems in which we are now ready to discuss a very important topic, that is poles and zeros of the system. Sorry. From now on, whatever methods we will be discussing, all are basically dependent on this pole and zero. So it is very important to understand what are these poles and what are these zeros. So first we have understood till now we are right now working in S domain. Okay, most of the time we will love to work in S domain for our control systems. Okay, now what are these poles and what are these zeros? So definition for pole is, so whatever there in the denominator, these are called pole values, and whatever in the numerator, these are called zero values. So we have seen this in a standard form, that is called pole zero form of a system, right? Now what are the pole values? Pole values are the values for which, or the values of S for which your denominator becomes zero, and effectively your function becomes infinity. Because there is zero in the denominator, that means your function becomes infinity. Okay, zeros are the values of S for which your numerator becomes zero, and if my numerator is zero, that means effectively my function becomes zero. Okay, so zeros are the values of S for which your numerator becomes zero, and poles are the values of which your denominator becomes zero. So let us take an example. We have same example which we have discussed in last video, that is k into s plus 3 upon s square plus s plus 2 plus s plus 5. Okay, now we have to find the values of zeros. Zeros are the values for which your numerator becomes zero. So k is my constant, no, nothing happens with my k. But if I substitute s value as minus 3 plus 3 will give me 0. Okay, so my z value becomes minus 3 in this case. Okay, similarly you can find the pole values for my system. If I substitute s is equal to 0, you will get denominator as 0. So first is my 0. There are two zero values, so I can have different poles at different zero values at s is equal to 2. So s square will carry two pole values, square term will carry 2. Then if I substitute s is equal to minus 2, that will give this term 0, so or effectively denominator becomes 0. So s is equal to minus 2 is another value, and s is equal to minus 5 is the last value. So for this system, there is 1 0 and 4 poles which are available in the system. So this is how you find various values of poles and zeros in your system. Let us take an example, one more example. We have g of s, h of s is equal to k upon s into s plus 1 and s square plus 2s plus 3. Okay, so in this case what will happen is, what are my zero values? There is no term of s in the numerator. Okay, so there are no zero values, so don't write 0 there, just write dash. Okay, there are no zero values for this system. What about the pole values? Will be represented as p, and the denominator for which denominator s values for which denominator becomes 0. So your s will be 0 at the start. If we substitute s is equal to 0, everything will be 0. If we substitute s is equal to minus 1, everything will be 0. And for this polynomial you need to solve this quadratic. This will be s plus 2 s plus 1 Okay, you can easily solve various polynomials in the denominator, and then you can have again -1, two poles at the -1 and -2. So this is how you can easily solve the polynomial which is there in the denominator and then find number of pole values. Again, there are 4 poles, no zeros, and in the previous systems also there are 4 poles and 1 zero which is there in my system. So this is how you can define poles. Poles are the values for which denominator becomes 0, and zeros are the values of s for which your numerator becomes 0, and this finding poles and zeros will be initial step for most of the techniques which we are using for stability. Okay, so that's why this concept is very important, the pole and zeros of my system. Okay, so this is what I want to discuss in this video. We will meet in next video for s-plane, the concept of s-plane, and moving towards stability effectively. So do like and share my channel, share it with your friends, subscribe my channel, and also check various playlists which are available on my channel for the control systems, mechanical measurements, and industrial automation. Thank you for joining.